Hello everyone, today we're gonna see my project blockchain health monitor system. I will show you my project quickly. Uh, First I am connecting to the instance and with EC2 instance. After that I am going to instance ID, and this is the instance ID public IPv4 address which you're seeing now. Subnet ID, VPC ID and platform AMI ID. And if you are seeing this, you need to copy this public IPv4 address, and I am going to new tab, and after that I am ex- uh, pasting this, and this is the my output interface of my blockchain health monitor system. See, if you're seeing this fluctuating, and if you're seeing right now, it is showing healthy offline and synchronized and full node validator miner. You can see upside block time, confirmation rate, active nodes. This is the blockchain health monitor system, and this is my output interface of system. I will show you now my paper work. My paperwork. This is my AWS project report developing a blockchain health monitor systems on AWS EC2. The report outlines the process of developing a blockchain monitor on Amazon Web Service using EC2. We successfully implemented a cloud-hosted web applications using AWS infrastructure as a servicing offering, ensuring security, scalability, and optimal performance. The goal of the project is to develop the React app, which is now running on the local host to AWS EC2 instances. And this is the output interface which I showed you just now. Steps to follow the uh, instances. First, to navigate to AWS service EC2 and launch an EC2 T3.micro instance using UBM2 AMI. Details of the AMI which you're seeing in the PPT. This is the details of the uh, AMI. After that, select the default configuration. Select allow SSS and HTTP traffic. Create a new key pair file and download it. After that, go to connect and use the given commands to connect SSH to the instance in local terminal. And this is the code which you are seeing now. And this is my blockchain health management system output which you are seeing now. After creating everything here, you need to copy the public IPv4 address, and after that pasting in the new tab, you can see the output interface. You can see healthy offline. It will be fluctuating. It will be fluctuated in it times. You can see the transition volume and block volume and block time and confirmation rate and active nodes. Now you can see the down also node health, network status, and health overview, node, everything. And this is the summary of my report. AWS service used EC2. We selected a T3.micro instance which is free trial eligible, and security groups, custom configuration to manage web traffic, elastic IP for a static IP assignment, route for DNS management, and IRMs. Software stack which we used: operating system UBNT server 20.0 for LTS, web server NGX, Node.js version 16.x, PM2 process manager, and SSL Let's Encrypt. Implementation process: AWS account setup. We need to create after that create an AWS setup IAM user with an appropriate permissions. If you navigate to next page, next slide, these are the after creating account, this everything we need to set the EC2 instance, and we configure the EC2 instance with the following specifications as you're seeing in the slides. After that, this is the security configurations: allowed SSH and enable HTTP, and also we should enable HTTPS, and elastic IP setup. Allocated a new elastic IP address associated with our EC2 instance, update DNS record, and server configuration. Basic server setup: update and upgrade system packages, install NB web server, configured basic rule servers, and development environment setup, install node.js npm and install pm2 for process management and setup necessary for development tools. And application development, after code management, setup for git for version control, configure development keys, and you need to transfer application code to server. After that, application setup and install the project dependencies, build the React application, configure it, and security implication is configure UFW, setup SS key, based authentication, implement fail to ban, brute force. After that, application security, configure SSL or TLS certificates, implement security headers, set up regularly security updates, monitor system and maintenance. And cost analysis, EC2 and elastic IP data transfer, estimated monthly cost into free trial, future cost consideration and recommendations, and optimize browser caching and security enhancements and scalability considerations. This is the conclusion. The development of React on AWS has been completed successfully. The implementation provides a stable, secure, and scalable hosting solution that follows AWS best practices. This setup serves a solid foundation for future implement scaling, short-term improvements, implement CI/CD, set up automated back systems, and configure advanced monitoring, long-term considerations, develop disaster recovery procedures, plan for scaling infrastructures, optimize cost managing. And thank you for giving this opportunity for the project.